everyone. So, in this unit or in this video, we will start with basic concepts of coordination compounds. This is in class 12th and CERT. Okay, so the first thing that is, what do you mean by coordination and what do you mean by coordination compounds? What are coordinate bonds, also known as dative bonds? So we will go with first basic explanation of these compounds, of these types of complexes. Okay, so first is, what is coordinate bonds or what are coordination compounds? So we know two types of bonds. One is, there are three types of bonds. First is ionic bond, second is covalent bond, and third type of bond is coordinate bonds. So first, ionic bond. Ionic bond, it is a type of bond in which one there are two atoms. Okay, one gives the electron and the other one takes it. For example, in ionic bonding, one is positively charged and one is negatively charged, so electron transfer takes place from one atom to the another, that is electron rich to electron deficient atom. For example, if we go with NaCl, example is NaCl. Na has 11 valency. Na has 11 electrons in it, 2, 8 and 1. 1 is its valency, and Cl has 17. So 2, 8, 7. Okay, so compounds or any atom is balanced when its outer octet or when its octet or outer shell is completely filled. So if we will if this Na will give one electron to this, then what happens? Na positive. Whenever any atom or element gives its electron, positive charge appears on it, and the one that takes up electron gets negative charge on the basis of how many electrons have been shared. Like here, only one electron, so only one positive charge will be there, whereas in this, only one electron is taken up by chlorine, so one minus charge. There is no need to mention one, single only charge means one. Okay, so this, now octet of sodium has 2 and 8, and chlorine is 2, 8 and 8. So the octet of both these elements is completed, so they form a complex like this, NaCl, in which the electron that is shared in between them is of sodium, that is sodium gives its electron completely to chlorine. Okay, this is an example of ionic bond. Now what is covalent bond? Covalent bond is the type of bond in which both atoms share electrons with each other. Here no sharing, it here donation, donating or accepting of electrons takes place. Okay, whereas in covalent bond, sharing of electrons takes place, mutual sharing of electrons. Like now this is an example of ionic bond. Now covalent bond. So covalent bond, example like carbon carbon bond. Carbon has 4 electrons. Carbon has 4 electron. Its atomic number is 6, that is 2 and 4. It needs 4 electrons to complete its octet. If or it has to donate its 4 electrons, and both taking and giving up of 4 electrons is is very energy radiant process, that is energy is required in large amount for this. Also a compound or atom having 4 electrons, if it will lose 4 electrons, it is not possible for carbon to be stable with 2 electrons, because it has it has nucleus that has four protons and four neutrons. Sorry, six protons are there, and only since only four will be remaining, it will become highly unstable, whereas taking up of four electrons, that is 2 and 8, if four electrons will be taken, energy is required to maintain or keep these four electrons in the shell, because it has capacity of only 6, and only 6 protons are in there, and if 6 protons and 10 electrons, compound will be highly unstable. So here, sharing of electrons, mutual sharing of electrons takes place between carbon, that is, or okay, carbon carbon, that is sharing of electron, that is one carbon from here. A bond consists of two electrons, and these two electrons out of these two, one is shared from this carbon and one is shared from this carbon. Other example is like hydrogen, H2. Hydrogen has electronic configuration of only one s, it has one s, so only one electron. So in order to make bond, two electrons are needed, so one electron from this hydrogen and one electron from this hydrogen. Both this hydrogen can give one electron and a bond is formed between them. Similarly, fluorine. Many examples are there like F2, Cl2, I2, H, H, Br, we can say. No, not HBr, because here ionic bond will be formed. Okay, this types of bond, O2 and 2. So, covalent bond is mainly formed with the atom that are not very electropositive or very that is electronegativity difference between the atoms are quite low. In that type of atoms, covalent bonding takes place. Now next example is of coordinate bond. So what is coordinate bond? Here here one electron gives one electron. Here one atom gives electron. Here both the atoms share their electrons, but in coordinate bonds, also called as dative bond. Its example is H2O2 example. Dative bond, also known as dative bond. So in this dative bond, one atom gives a pair of electrons, that is both two electrons to the other one, electron deficient atom. Okay, like example, like uh, in which for example CO3 2 minus, in this C double bond O, C double bond C O single O minus, CO minus. Okay, let's say CO minus we will take. So here, so example of coordinate bond is ammonium boron trifluoride. Ammonia boron trifluoride, like ammonia having a pair of electrons in it, and boron trifluoride. Okay, so here you can see boron octet is not complete even though three fluorine atoms are joined to it. So nitrogen gives its two electrons and boron does not have any electrons, so this nitrogen will give its both electrons and bond is formed. So in a bond, both the electrons is of nitrogen, like C. This bond has both the electrons given by nitrogen. So this type of bond is shown by an arrow pointing towards the one that accepts the electron, and means arrow to side is which accepts the electron from other atom. Okay, so these are the three types of bonds. Now we will start with what is coordination compounds and double salt. Now there are two terms. First is coordinate or coordination compounds, and second is double salts. Okay, so what do you think, what is the difference between these things? Okay, so let me start with it. Double salts. Okay, both these types of both these are made up of, two we can say two types of metals, two types of compounds, but what is but the difference between these is it has its identity only in solid state. Identity is retained only in solid state, and as soon as it is poured in aqueous or water, it loses its identity. That is, double salts are like it gets dissociated in both of its ions that are double salt, and lose its identity in aqueous state. Okay, now what are coordination compounds? Coordination compounds that does not that are quite stable enough that they do not stable enough that they do not lose its identity in aqueous state. So it retain its identity in solid as well as in aqueous state. So what is let's say what are examples of double salts? So example of double salts, like example is Morse salt. It can also be called as ammonium iron 3 sulfate. We will get to know how this is written in next further videos. Okay, or other example we can say is potassium, like potassium ammonium sulfate. Other name is potassium aluminium sulfate. Like potassium aluminum KAlSO4 whole twice. So when it is poured in aqueous state, potassium and aluminum will dissociate into its ions, or two salt means it will get dissociated. That is uh, ammonium iron sulfate. Example is like chemical formula is ammonium iron sulfate. Okay, so ammonia and sulfate, it will get dissociated. Whereas in coordination compounds, there is no such losing of identity. Okay, so we will start with coordination compounds. Now, what is the representation of coordination compounds? Then one of the important thing is how a coordination compound, or how it is represented, what are its significance, what is what. Okay, okay, so we were talking about density. So what is density? So like this example, H2. A oxygen has two lone pairs. So either one of the two lone pairs can be donated to the metal with which it can form a coordinate bond. Okay, so coordination, what can we write as coordination of a ligand to metal center, means in how many in what form coordinate this ligand is attached to metal or coordinated with a metal. Okay, so if we will see, there is more classification of this denticity. Okay, ligands can be classified on the basis of denticity. So classification of ligands. So ligands on the basis of denticity means in how many donor atoms are present in the ligand. In that form, it can be no. First, it is divided in three categories: monodentate, only two, sorry, and monodentate and polydentate ligands. Monodentate are those ligands that have only denticity of only one, and polydentate two or more ligands having denticity of two or more than two are known as polydentate ligands. Okay, so these ligands have only one donor atoms. Okay, only one donor atoms, and hence the density is 1. Or atoms or ligands having density of 2 or more than 2 are polydentate ligands. Okay. So now this monodentate ligand can also be classified in categories: neutral monodentate ligands, positively charged monodentate ligands, and negatively charged monodentate ligands. Negatively charged monodentate ligands. Okay, now let me give some examples of neutral ligands, then positively charged ligands, and negative. Like I will write and you write their names as well. I will just tell. Like water, it is also known as aqua. In coordination compound, this nomenclature is quite different. Okay, aqua. CO, carbonyl. CS, thiocarbonyl. Since they don't have any charge on it, NH, that is ammonia. Phosphine. Okay, alkyl ammonia. This is alkyl ammonia. Trialkyl phosphine, like phosphine, trialkyl phosphine. Pyridine. So these are example of neutral ligands. Now positively charged, like nitrosonium ion, NO positive. This is nitrosonium ion. Then hydrazonium ions. Hydrazonium ions. Hydrazonium ions. Negatively charged are like fluorine, chlorine, or we can say it is fluoro. Negatively charged, there is IDO difference in nomenclature. It comes fluorido, like IDO in last change in nomenclature. Chlorido or chloro, bromido. Okay, hydroxo, hydrido, amido, amido. Sorry, this is not amido. Nitrido, amido, amido, amido. Some pronunciation different. This one is hydrido, hydroxo, and this is bromido or bromo, or this is chloro or chlorido. Okay, so these are some examples of neutral, positively charged and negatively charged monodentate ligands. Okay, now polydentate, this can include bidentate, tridentate, tetradentate, pentadentate, hexadentate. So let me give you examples of each one. Like bidentate, these in this bidentate ligands are those ligands which have two donor atoms. Denticity means how many atom in a ligand can donate to a metal atom. So in bidentate, there are two donor atoms that can attack to a single metal. Okay, single metal atom. So bidentate. Tridentate ligands have three donor atom. Tetradentate ligands have four donor atoms. pentadentate 5 donor atoms, and hexadentate 6 donor atoms. Like examples of bidentate. Example of bidentate ligands like CH2, CH2, NH2, NH2. See, both this nitrogen has lone pairs, and if metal is present, it can also be. So this is example of bidentate ligand. Example is ethylene diamine. So this is example COO minus, COO minus 2O. So it can donate with its 2. So this example, basic example that are present in book is oxalato. Okay, ethylene diamine is represented as En. Then okay, these are some basic examples. Okay, now tridentate ligands that has three donor atoms or three donor sites to which a single metal can attach. Like tridentate, example of tridentate, NH, CH2, CH2, NH2, CH2, CH2, NH2. So this is diethyl triamine, diene. So it has three donor atoms, 1, 2, and 3. These three are donor atoms that can attach to single central metal. Now example of tetradentate. Tetradentate. It has four donor atoms like CH2, CH2, NH2, sorry, NH. This is again attached to CH2, CH2, NH2, CH2, CH2, and NH2. So 1, 2, 3, and 4. In such way, it can increase its ring, and this is known as triethylene diamine. Triene. Okay. Similarly, pentadentate and hexadentate can also be found in this. Now, another type of ligand is bidentate ligand. Ambidentate ligand. So next is ambidentate ligands. So what are ambidentate ligands? Are ambidentate ligands. So the monodentate ligand which have two or more different donor atoms and can coordinate with metal with either of the two or more different atoms. Like, so let me write monodentate ligand which have two or more different donor atoms and can coordinate to a metal through either one of the two different atoms. Okay. For example, SCN minus. So it also has sulfur and nitrogen. The lone pair of electrons are present in both nitrogen and sulfur. With which site the ligand can attach with a metal? Okay, so this only one atom will attach to metal, but the ligand has two or more different donor sites. Another example is NO2 minus. It also has oxygen as well as nitrogen. Okay, two oxygen and one nitrogen, that is two different atoms, and out of these two different atoms, one can coordinate with a metal. Okay, next is bridging ligand. It is the ligands with which one or two different donor atoms have at least two pair of electrons and share those electron pair with two metal atom simultaneously are bridging ligands. For example, see, okay, this nitrogen and this. So this is bridging. This ligand is such that it is bonded with these and can donate with two different metals. Okay, so it has it till now what we have studied is the ligands attached to only one metal in different with different density, or the ligand may have two or more density, or single ligand has two donor groups out of which one can donate, or which out of that two one can form coordinate bond. But bridging ligand is single ligand bonded to more than one metal. So this is the difference between bridging ligand and other types of ligands. Okay, so here classification of ligand ends. In next video we will study Werner's theory, and nomenclature also we will study.